Okay, it is time to talk about drive shafts. Yep, that thing on the floor. All right, let's talk drive shafts. I don't know if this is going to be in the same video as the rear axle or not. If it is in the same video, then nothing to say. If this is a new video, hey, thanks for watching and welcome to what is still day 10. So as far as drive shafts go, when I first started this build, the plan was to change the two-piece drive shaft out and install a one-piece drive shaft. And that's all fine and good, but there are things to take into consideration when doing the drive shaft work. First thing is critical speed. The longer your drive shaft is, and depending on the diameter and what the material is made of, changes the critical speed of the drive shaft. Critical speed is when it starts basically whipping around and it's going to fail. This car originally had a two-piece drive shaft. I think for a couple reasons. One, because it was really long, excuse me, and two, because the car is so low with the step-down design that to get a drive shaft that long, it would be a pretty steep angle with the floor pan the way it is, and you wouldn't be able to use the rear cross member. You're looking at me. The rear cross member the way it was designed to be made. And that is the cross member I'm talking about. Instead of looking at my mug, I was thinking of pointing the camera up that way. But basically that oval hole there through that cross member, with a drive shaft, one piece very long, that's not going to be able to be used because of the angle. So if I was going to switch to a one piece, I'd be cutting that all out. So as far as critical speed goes, the drive shaft would have ended up being about 60 inches each U-joint to U-joint centerline in length. Calculations show critical speed on that to be about 4,500 RPM. Now that's, I guess you'd say that 4,500 is not too bad. You're not going to run 4,500 in high gear, right? Well, if you're running like a turbo 350 and a 373 gear, you're going to be spinning 3,500 easy on the highway. So 4,500 is not that far off. Now the problem comes into like this from adding overdrive. Now the rear end is spinning faster than the engine. So if you decide to get on it out in the highway and you wind the motor up to 3,500 in overdrive, which you're going well over the speed limit, but still the drive shaft's spinning much faster. Actually, with the 0.7 overdrive compared to a 1-to-1, the drive shaft is spinning much faster than the engine. So if you've got the motor spinning 3,500 in overdrive, there's a good chance the drive shaft is close to critical speed and it's going to get scattered. The only way to get around that is to either shorten the drive shaft, which we can't do being a one piece, or make it a larger diameter and or different material. So like I have Silverado drive shafts here that I could shorten up. Those are, I have some that are like 4 inches, 4.5, 5 inches even, and that would be great to use for this car for a drive shaft. Only issue is the transmission tunnel is nowhere near big enough to handle something like that. So that needs to be, I'm looking at it now, I have to cut quite a bit out of it and raise it in order to even use a drive shaft like that. And that's fine. I don't have time for that right now. This car needs to get out. So rather than reinventing the wheel, I am going to use the original two-piece drive shaft, which is in great shape, and make some modifications. So this is what I have to do. So this is the original two-piece drive shaft here. Now, a couple things have to be done. The way this drive shaft works is the front half, obviously, connected to the transmission, and came back here to this carrier bearing. Now I have a grease fitting here, which I've pumped some grease through to lube the bearing. I don't know if this is supposed to slide or not here. It's not moving right now, I'll tell you that. And probably because the front half of the drive shaft is basically fixed. It's not going to move once it's installed. So it could just be rusty. I'll have to have somebody who actually has a Hudson tell me if that is supposed to slide off and on that right there. I don't know. Now the rear half does move in and out there into the carrier bearing, and that's because when the rear axle moves up and down the leaf springs, this drive shaft has to get longer or shorter. So the rear drive shaft actually has some movement to it. Not a lot. I think there's maybe 1 inch of in and out play in that carrier bearing. But a couple of things come into play here because I switched to the S10 rear axle. So now, because the rear part of the drive shaft comes from that carrier bearing mount back to the axle, that length has to be pretty spot on, because you only have an inch of in and out play on that carrier bearing when this thing moves up and down. And a quick measurement showed me that the distance from the center line of the tube, which is where it's mounted to the car, up to the center of the U-joint is about an inch shorter on the S10 rear versus the original rear. So what that means is that this rear half of the drive shaft is going to be an inch too short. If you pulled it all the way out of the carrier bearing, it would fit, but now it has no length, or rather it has no more adjustment, and when the car comes down on the springs and this needs to get longer, it's not going to happen. So basically the rear half is an inch too short. The front half of the drive shaft is much too long, because we now have the 60E, which is much longer than the original 3-speed manual transmission. So how am I going to get around all this? Well, the variable here is going to be where that carrier bearing mounts, right? So what I'm going to do is I'm going to cut that section from the mount there, this piece here. I'm going to cut this loose and move it rearward 1 inch. That will make up for the inch that I'm missing as far as length on the rear. Once that's set, then I can get a measurement up to where I need to be to the transmission, and we're going to shorten the front half. So this is going to be a two-step thing here. As far as U-joints, that U-joint there, I think that is a 1310 from what I'm used to. Working with 1310s, 1330s, and 1350s. I believe that is just a common 1310 U-joint. And because I'm a hoarder, and I found one here, I actually have a yoke from probably a Turbo 350 that used a 1310. So my factory joint on the Hudson is going to work for the front half. For the back half, it's also a 1310, but the S10 rear there uses a 1330. So I need a conversion joint, 1310 on one side, 1330 on the other. And again, because I'm a hoarder, I have them in stock. I've done enough of these that I keep that stuff around. So I'm going to swap out that rear U-joint for a conversion joint. And yeah, we should be able to make this work, as long as I measured correctly. We'll have to see. All right, so we'll get this carrier bearing mount out of here. One other thing I forgot to mention was that using a two-piece drive shaft does change the critical speed. It makes it higher. I have yet to find formulas to figure out how it works or what it is, because this two-piece diameter is a very small two-piece diameter. This two-piece drive shaft is a pretty small diameter, yet it's able to be used in a very long drive shaft. So the two-piece shaft must make quite a difference in critical speed. All right, there is my cross member. Right now, distance from here to here is 6.5 inches. I'm going to slide that forward 1 inch, and weld it in the new position. All right, there we go. Cut that brace out, moved it back an inch. So now my rear section of the drive shaft will be the right length for full suspension movement. So when this is at full droop, like now, the drive shaft will be at its shortest point, and then at, I guess, full compression, you'd call it, it'll be at its longest point. So at ride height, if all goes well, the slip joint should be right in the middle. So next is the front half of the drive shaft. So what I did was I took a measurement from the center of this hole, which is where the carrier bearing is going to be, to the center where the U-joint is going to be there, and that's 29 inches. And then I'm going to add, call it an extra ½ inch, because if the center is there, we're going to go out to there for measurements, just easier. I'll call it 29.5. So this is a little different than the way I normally make a drive shaft, only because it's a two-piece. Drive shafts should be in phase. Something you'll notice, this rear drive shaft here, if you look at this is up, the yoke is up, and it's up straight up on the other end as well. That's called in phase. You wouldn't want this one straight up and that one at horizontal. That would be out of phase, no good. So looking at the front half, this is actually the end of the front drive shaft. And if you follow it across, I'm not perfect. It's actually a little bit off. Now, that could be because this section here may actually come apart, and somebody had that off at one point, and when they put it back together, they put it off one spline or something. But right now, like I said, that doesn't want to move, and I'm not going to beat on it. So I'm going to shorten this drive shaft, and I am going to put it back into phase. So when I put that yoke back on, it's going to be straight up and down along with this end. And I don't know how much I'd take off of this yet. Like, my measurement is going to be 29.5 inches from this center point here to the end of my yoke out here. So first thing I got to do, I got to cut that yoke off. And I'm just going to do this with hand tools. I'm not going to use a lathe or anything crazy, and it's going to work just fine. So first I'm just going to use a cutoff wheel and cut along this weld, not too deep, because usually this yoke will have a section that actually comes into the tube, and I just want to split them apart and get that off, and that'll be the first step. All right, so this drive shaft's going to need like 10.5 inches taken out of it, so I don't have to worry about making a perfect cut right here. I just want to make sure I don't hurt my yoke. Now, this is not like a, I don't know, newer, but 60s and up drive shafts I'm used to working with. It almost looks like a fusion weld or something, like the yoke is inside the tube, and it just looks different than what I'm used to. What I'm going to do is I'm going to cut around the outside of the weld and see what it looks like when I'm done here. And I'm just cutting through the outer tube. I don't want to go too deep and cut into the yoke. I just want to separate these two sections. Nice. Hopefully it's on camera. But I just cut through the tubing and didn't affect the yoke any. Cool. Nope, it wasn't on camera, so there's a better look at it. Just cut through the tubing nice and slow and didn't get into the yoke. But that's all there is to it. Now, I've got to cut down the tube, shorten it up. All right, so when measuring for a drive shaft, normally you would put your yoke all the way in, you know, back it out maybe 1 inch, 3/4. Depends what kind of suspension you've got here. Leaf spring has more movement than, say, a 4-link or so. But in this situation, the front half of the drive shaft is fixed. It's just going from the yoke to the carrier bearing, so it's not going to move in and out. And really, this is just a dust seal, this back here. The seal is here and the bushing is in here. So in this case, when I take my measurements, this is kind of hydro locked here because it got fluid in it. But I want this all the way in up to the dust seal, and that's where I got my measurement from there. That's actually sticking out of the transmission a good inch, and it would push in if it had to, but not gonna. So from that point where the yoke was in up to the dust seal back to my center line, call it 29 3/4. So that's what I'm cutting this down to. And I'm measuring from the center of my carrier bearing to the end of the yoke here. Made a mark on the drive shaft, put a hose clamp on it so I have a straight reference. And I'm just going to use the cutoff wheel and cut right behind that hose clamp. Get some light over here so I can see what I'm doing. All right, moving forward. Just cleaned out the inside of the tube with a carbide bit. There was actually a little seam in there where the tubing was welded together. So I just had to bring that down a little bit. Cleaned up the rust off there and just knocked it together. And I have it in phase here. I have that yoke straight up and I have this one straight up. So all that's left is to put it up there and see if it fits first off. But I have to put the yoke on this side. Forgot about that. So I should probably do that first. All right, yoke is installed on the original 1310 joint. This is not welded yet. It's just put in to check for length. And carrier bearings mounted. This is perfect. Didn't give myself any leeway. The yoke is right, what's that, maybe an 1/8, 1/16 from the dust seal. That's perfect. That's perfect. And then down here, the rear half is, I mean, to the 1/16. It's right there. Perfect. To the point where you can't, I can't get that installed yet. I have to lift the carrier bearing up out of the mount and then push the front half forward, and then I can get that fit in there. But I got to put the conversion U joint on that first to go from the 1310 to the 1330, I believe it is. and get that done. So yeah, things are going well. The things going in good. So that is going to be it for today, though, because I'm beat and I started late. So I think we'll end this now. And then when I come back, we'll get that welded up, or at least tack welded. I'll show you how I make that straight. And finish mounting the carrier bearing, get the conversion joint on the back, and the drive shaft will be done. Pretty good. All right, so thanks for watching. And that is the end of day 10, I think this is. We'll see you on day 11.